Hello and welcome to my video 6.5 Multiplication and Division of Inequalities. The purpose of this video is just to show you that multiplication and division of inequalities is the same as with any other linear relation or equation. Okay, so hopefully at this point you've seen 6.1, 6.2 that show you how to do the regular algebra, and hopefully you've seen 6.3 that tells you a little bit about these line graphs and all the different types of inequalities. If not, I would suggest you watch those videos first. Alright, so we're going to start off with an easy one that we know probably since about grade 7. And it's this equation here, Q1, question 1. So we're going to start off by dividing by 2, which gives us x equals 3. Which is really nice because we can just put down our dot. Okay, that's easy. X equals 3. So if x equals 3, so if x is the thing that makes this true, and in this case the only thing it can be is 3, if x equals 3, the left side of our equation is 2 times x, which is 2 times 3, which is 6, and the right side is 6. Which makes sense, they should be equal because that's what we've been saying. So that both sides are equal, it's teeter-totter, they need to be equal. Okay, so in this one we have 6 and we have 6. They're both 6, right? Now if we were to, just like we did here already, if we were to divide by 2, well, this one would go over half, from where it started to halfway between it and 0. And so would the other one. If they both move over by a half, they're going to equal the same thing. Okay? And that's basically the point. They're supposed to change by the same amount. And we're going to show that that's true for all of these different things. Even if it's greater than or less than, if you divide by 2, it changes the amount equally between the two. Okay? So you'll see that in a second as we're about to show. Okay, that one makes sense. So let's try this next one. We're going to divide by 3, inverse BEDMAS, which would give us 5 is greater than x. Okay, so let's draw that out. First of all, it's 5 but with an open circle, and x is smaller than the number 5, so we're going this way. Excuse me. So we need to choose an x smaller than that. So if x equals, I don't know, 4, okay, we need any number that's smaller than that. So if x equals 4, then the left side is 15, right? And the right side is 4 times 3 is 12, and indeed that does make this inequality true. 15 is greater than 12, so that's good, okay? So maybe I will color this one in red just to make it clear. So 12 goes here. 15 goes here. And if we divide by 3, like we did before, then 15 goes all the way to 5. Or maybe I'll do that on the bottom, all the way to 5. Okay, and 12 goes all the way to 4. So 5 is still bigger than 4, just like 15 was bigger than 12, and this is still true, right? So it works. So let's try out one more just to double check. Well, we divide by 2, so we have 8 is less than or equal to x. Okay, so let's put that down. It's going to be a filled in circle because it's also got that equal to sign. And it goes, x is the bigger side. See, I think about it like this, like I talked about in 6.3, the bigger side is the bigger number, okay? So then it goes all the way this direction all the way till the end of my number line. Okay, so that's my fantastic number line there. Okay, so now if x equals, needs to be some number bigger than 8 or equal to 8, but I'm going to choose 10. Okay, so if x equals 10, then the left side is still 16, and the right side is 2 times 10, which is 20. Okay? That does fit, so 20 is greater than 16, greater than or equal to, in this case just greater than. So let's put those on our line here. So 16 right there, 20 right there. So 20 moves over, if we divide by 2, moves over all the way to 10, which makes sense, halfway, and 16 moves all the way to 8, which also makes sense. It's halfway. Okay, so both of them move by a half, which is good, but you'll notice that the purple one is still smaller than the red one after it moves. So it still fits that inequality that we discussed at the beginning. So all of these sort of are examples of how inequalities for multiplication and division work the same way as for equations and relations. Hopefully this helps, and good luck.